is gone. Oh, that's not.
Tyler used to I don't think he's going to be watching the video though.
Yes. For next year, none of you should be aiming to get to senioritis like superlative and beautiful.
I'm going for class with the best smile.
You go for best smile and top smile, but not senioritis. Yeah. Don't be lost.
It's right here on my left. Just shades from the bottom.
Sounds good.
Wait, how often do people actually get lost?
Not so much. Do you guys know what I mean when I say
Oh,
don't be lost?
like,
I don't mean don't go wandering, don't go like just chilling on your phone, like in the bathroom, don't go like, hey, let's go talk to JC for a while. Let's go buy something from the snack shack, whatever it's called. The Campus Kitchen.
Wait, it's what?
I don't know, I call it snack shack. Snack shack?
Yeah,
Yeah, everyone calls
it's
it.
from Miro. Go.
Stop. I heard you just Alright, you guys are just talking, that means you're ready. Here we go. Oh, hey, P.S. P.S. This problem is the reason why you're allowed to have a graphing calculator, at least for part of the test. So, grab it out, open it up, because just because we're supposed to be graphing stuff does not always mean we do it by hand. Right? Yeah, graph 1200, that'll be fun. So have your graphing calculator out. I do not full screen it so I can still access the graphing calculator. It should be coming. Where are you? He's coming. Alright. When you translated 1 and 2 and 3 back to like what? Pre-algebra? Is that when you first started translating like the sum of two numbers is? Hopefully you read the following and were able to translate it in the following way. Now yesterday I made, who was X? Is that Creams? Cream pie. Chocolate covered creams was X, and then chocolate covered nuts was Y. Let's see, what are the good ones? Macadamias? So do the macadamias and the creams. So otherwise you guys all start snickering. Anyway, so the combined production level should not exceed 1,200 boxes per month. So we have the creams and we have macadamias. Should not exceed, what inequality did you guys put in? Should not exceed.
Less.
Yeah. Less than, technically, or equal to. Why? Yeah. If it's 1,200, that's not exceeding. I agree. There's one condition, one inequality. Number 2, the demand for a box of chocolate covered nuts is no more than half. No more than is. Okay, well, hold on. Macadamias is Y. Is, that's like a space for an equals or an inequality. Is no more than, oh, stink. Is no more than, what'd you guys put for that one? Yep, less than or equal to. Is no more than. Y cannot be above X, but it can be equal to. Or less than. There's condition number 2. And condition number 3, the production level for chocolate covered creams should be less than, okay, wait, creams, that's X, right? Should be less than or, oh, well, they just told it to me. Okay, I'll take it. Should be less than or equal to 600 boxes. Plus, they were really nice. 3 times, they told us all the words. The production level for the macadamias. 1. Constraint, 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 let's go. Here's an important connection you have to make. We said yesterday, the profit, are we using it right away or saving it till the end in the table? And the answer was saving it. So if we're not using the original equation, what are we going to be working with right away?
Those 3.
And how do we work with those 3? We say, hey, it's time to graph them. Hey, it's time to graph them. But to graph them, don't we have to get y by itself? So before we even go to our graphing calculator, we need to, hey, it's all right to have a little bit of sass. Negative x plus 1,200 good the way he is. Y is less than or equal to x, which would be what? 1x plus 0. Mental mathers. Y by itself. What's the bottom one?
Y 600 x.
I like 1/3 x minus. Got it? What's my inequality though? Greater than or equal to. Because if the y stays here, then the inequality, the alligator is eating him, right? Did anybody learn the alligator, the big mouth, it's a big number? No?
Yes.
You can even like zoom in, you can say like, you can put little teeth on him. Alligators like big nails. Anyway,
Wow.
you're welcome. So, let's take these all, let's graph them by hand. I'm not feeling it. Alright, so, what are we going to do instead? Graphing calculator time. Go through them all in. Long story short, the test is going to take time. Not that it's impossible. We have substitution and elimination, but it is going to take time and you might run out. Nice thing is, it's not on Monday. I spread out this section so that we wouldn't have it Monday. Chapel day, not a good idea. After a weekend with a playoff game, which you all will be going to because you didn't come on Wednesday.
Sports games.
Yeah. For those of you that come to sports games. Anyway. What quadrant are we looking in again?
One.
Yeah, remember the understood one, they didn't tell us X has to be positive, but what production company is going to have negative boxes? None. Anyway, production. They could have something like where they have a loss in a store and like a negative profit, but not for production boxes. So the window, I'm going to say, you guys can go do your Zoom fit, whatchamacallit, but I don't really like that. We need to go high on the X's, right? We need to go high on the Y's for sure. X's, I don't know, let's try 500 first of all. The Y's, I put a little bit negative, like -10, just to have a little bit, but not much in comparison. This is technically the first quadrant. 1200 I see as my intercept. Maybe we should go up to like a 2000. Make sure that 1200 is in there. I see my y-intercept right there. Let's see how it looks. Okay, not too shabby. Oh, we need to go a little bit further. There's an intersection point I can't see. Let's go find that real quick. So maybe X up to 1000. Which maybe some of you guys would have guessed if I had let you choose first. Do you guys see how, there's a whole, remember, how many equations are we supposed to have? If you just saw those two and didn't keep going, you might not have realized, oh, stink, where's my third equation? Maybe our window needs to be even a little higher. Now, as I look at my window, 2000 is a bit extreme. I don't think I need it quite that high. Let's go ahead and just do a little bit above 1200. Then my X max, there's another intersection I'm missing, so let's go a little bit further. Once again, yes, you guys could have done Zoom fit. Maybe it would have helped. I think there's 1, there's 2, and there's my, hopefully I have my intersection. Booyah, 3. Now at this point, could you do the little shading thingamabobs with your graphing calculator? Yes. It's going to get kind of messy. So here's what I would do instead. I would go ahead and just try to think through it logically, meaning what are all the inequalities? Boom, boom, boom. Ooh, well. What's the inequality of the first one with an intercept of 1200? That's the highest, right? He says what? Go below, right? So I'm going below him. Let's do the next one. Y is less than or equal to x. Where's that intercept? And x plus b would be 0, and which one hits at 0, 0? This one. Where am I shading? Below. So far I have below that guy, below this guy. Well, who's the last equation? It must be this guy. He's above. Question, do you guys see the overlap? Isn't the overlap going to be approximately? Right here. You guys agree? Less than the 2 higher ones, but above the other. So So number one, we save time not having to worry about silly inequality things. And number two, we see this picture a bit clearer. Question, what are we supposed to be pulling out of this picture, guys? Vertices. Good, the points. I see a vertex here at 0, 0. I see a vertex here at the intersection between, oh, that's between these two guys. I see an intersection here, that's between these two guys. If we were to number our equations, this would be 1, this would be 2, this would be 3. So this one's the intersection between 1 and 2. This one's the intersection between 1 and 3. And then we have this guy, who's the intercept of the 0 of 3. Now the nice thing is we know this guy right away. I would say. We know 0, 0 just by looking at it, right guys? Okay. So when we go to make our table, we can go ahead and say, sweet. Our goal is to test, and we start by finding all the vertices. So 0, 0 is the first point I'm going to put in. But we're using our graphing calculator, aren't we? So to find the intersection between 1 and 2, can't we just use our graphing calculator to find that intersection? And the answer is yes. Some of you guys already found it. Just a real quick review for those of you that are like, wait, what? Remember the intersect feature, number 5? We just need to make sure we're on the right graphs. Yeah, good. I'm on that one. Hit enter. I'm on the one right next to it. Hit enter. Those are the two that I need. Go find. Yes, go. Intersection is the point 600, 600. So let me erase the 1, 2. And say, hey, we found out who he is. Oh, I erased my lines too. That's 600, 600. Has anybody found the next intersection, the one between 1 and 3? Okay, go find it for me. 1,050, that sounds right. And what was the Y value? Okay. No, I trust you. Caleb, backs you up over here. And then number 3, wait, that's not an intersection. How are we going to find him? Yeah, can't we find the 0? Which you could go ahead and try to find the 0 on the graph, or you could just say, wait, that's equation 3, set the whole thing equal to 0. Add a 200, multiply by 3, that is going to end up being 600, 0. You want to double check with your graphing calculator? You can. Double checking is never bad. It's called discernment, but not bad this week. Life lesson though, discernment is important in all areas. So we have the point 0, 0, we have the point 600, 600, we have the point 1,050, 150. Some of you maybe are already plugging in because you know where we're going. We're going to testing each of these points in our objective function, which was, I think, profit. Wasn't that the objective of this business?
Yeah.
I think so. Usually is. P equals, or nonprofits, but even nonprofits want to have the money to actually continue operating. $1.50 times 0 plus $2 times 0. I think that's 0. Okay. The bottom one I think is 900, right? $1.50 times 600. 600 plus 300. That's 900. Making nothing profits you nothing, but it also, making nothing loses you nothing, but it also profits you. That's the unwise steward kind of buried the talents in the ground. Something similar anyway. 600, 600, what'd you guys get? This is all money technically. Here to label it. How about 1,050, 150?
1,727.
Someone back up real quick. Is something weird? You okay? Austin has something different. What do you have then? 875?
Yeah.
Okay.
I probably do it.
All right. Still, this is the winner, chicken dinner. Got it. Now, if this was a cost problem, would we be trying to find the max? No. No, but it's a profit problem, so we are trying to find the maximum. So in order to, in answer to their problem, we would say, or their question, we would say, what is the maximum monthly profit? The max profit is, this is our of answer, 2100, at or when, to make it a little bit nicer for the context of the problem, when producing 600 boxes of each. I'll say the bear because my room is all used up. Does that make sense to you? We use what we know. We can use our graphing calculator to simplify things like intersections and zeros, etc. We could use it for the shading, but I just think it gets more complicated. We need to clearly see those vertices. Watch out for your windows. Okay. Before we're done, which basically we are. Yeah.
What did you say? Oh, 600.
Oh, I was trying to connect it to that problem we did yesterday, just to get this wording down for you guys. That if you're trying to maximize, there's an of, like what the max value actually is, and then there's a when or an at. Does that make sense? Yeah. Good way to catch my emphasis there, because it was definitely. Because this is going back to the, actually, we just had it up there because of Austin's question. The example that we did, which was not a word problem, it was just like, hey, here's lots of expressions, go figure it out. Here's the objective, here are the constraints, go. There is another way of looking at these types of problems. And you don't actually have to write the next page I'm going to show you, just kind of think through with me, and then we'll write down the last page. That kind of expands on it just a little bit, okay? We did, hey, let's find all the vertices, let's test all the vertices, yeah, go. Then we went over to say, what about the interior points? Is anybody going to be higher? And our answer was, well, first of all, we made a mistake, we went back and fixed it. And then second of all, no, none of the interior points are going to get higher. That 0.21 was in fact the maximum, but there's a way of graphically looking at it. There's a way of graphically looking at it. When you get the original objective, which for this problem was, I think I should have figured it out beforehand. Z equals, is anybody back in their notes looking at this? What was the Z for, okay, 3x plus 2y. I was too lazy to figure it out in my head from what I had. You could think about the objective in terms of y's and x's, in terms of, hey, I could get y by itself. This is the same equation, just rewritten, getting y by itself. However, where does the z show up when we get y by itself? Where is the z? You see him? Who is he in? Who is this guy? This is a line. This guy must be the intercept, the y-intercept, right? So if z is in the y-intercept, and if z can be many different values, z is in the y-intercept, z can be many different values, then this line with a slope of -3 halves can actually be many different lines. This line can be many different lines. Now, why are all the lines parallel? Because all the different lines, guys, have to follow that equation where the slopes are all -3 halves. Okay? All the slopes are -3 halves. There could technically be infinitely many more lines, right? Because there are so many lines that could fit in between, meaning at all the different places. We've just shown a few representative lines. But out of all of these lines, if they have to meet or be within the objective or the shaded overlapped region, the question is, here's another way of looking at it, how long or how far can I go until I can't go any further, right? None of those work because they're not in the shaded region. Or I should maybe use a different color, there's a lot of red up there. None of these work. I have to stop right here. Does that make sense? It's the furthest I can go. Now, why is it a big deal? Why do I want to know the furthest? Let me get rid of all these. Oh my goodness. A lot of lines. I had too much fun. There we go. Oh, too fun. Okay. I'm thinking about that because if z is the y-intercept, then what z over 2 is the y-intercept. The question why we can look at it graphically, why we're looking for the farthest out it can go is because the farthest out it can go is also the highest it can reach. The farthest out it can go is also the highest it can reach. And the highest it can reach means the maximum to find z. The highest y-intercept will get us the greatest z, and the greatest z is the objective. So if I get that 4 is the y-intercept, I can say 4 is equal to z over 2, hence z is equal to, which also ends up being the 0 of the line way down here. So that's one way of looking at it. The farthest out a line with this slope can go, hence getting the highest y-intercept. Now, the reason I showed you that is because some weird things can happen when you're solving. Some weird things can happen when you're solving. Meaning, now start writing. There are a couple unusual things that can occur. They're not bad, they're just unusual. It's up to you to summarize. Long story short, the first unusual thing that can occur, the max or min can occur at two different vertices. You can just write down the highlighting if you want. Unusual characteristics, unusual solutions. The max or min, similarly, can happen at two different vertices. Some of you are like, well, how is it possible to happen at two different places if there's one furthest point? Well, this is a good example to show you. This example, you start with an objective, and if you were to do what we did just a second ago graphically and solve for y, you would end up with y is equal to, negative x though, right? Okay. Negative x plus z over 2. Which means, okay, all the lines with slopes of negative 1. Now, just to kind of show what happened in the last graph, negative 1 would connect downhill lines from 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, he's up there, 6 to 6. If only I was actually on point. You see, I was trying to be really careful with that line. What's true about the furthest that the lines can go? It can be anywhere on, so if there is more than one vertex, it means there are actually many different ways to get that maximum value. Now the nice thing is we don't have to like graph these things necessarily, well we do if you graph them to get the vertices. We don't have to necessarily do this graphical procedure every time. And the only reason this one actually ends up having the 2 is because the line happens to have the exact same slope as that area or that cutoff. If the line had any other slope, it wouldn't have more than one vertex, and it wouldn't connect the 2. So there technically are not just 2 solutions at the 2 vertices, there are technically infinitely many solutions between, but that's not the point. The point is, we use the vertices to find the maximum, and the question is, will we find the maximum value of, also remember the of, are we going to find the actual value using the vertices? And the answer is yeah. We're actually going to find it twice. So our goal is not per se, or is not so much the at, even though we're going to say the vertices that get us the maximum value, but our goal is the what is the maximum, what is the highest I can find. So when you see down here they're testing all the points, they're testing 0, 0, y because it's a vertex. They're testing 0, 4, y because it's a vertex. They should have also, or we should, keep testing the point 2, 4, testing the point 5, 0, testing the point 5, 1. If we were to keep going, long story short, plugging into 4 mental matters, you beat me there. 4 and 8 would make 12, the sum. Plugging in 5, 10 and 0 would make 10. Plugging in 5 and 1, 10 and 2 would make 12. So don't be stressed or don't get worried or concerned, not that you necessarily would, but maybe. If the maximum happens more than one place, we can still say, cool, no big deal. Sure, it happened more than once, but we can still say we know the maximum value of 12. And since we're trying to explain how we got it, we can say at, and we would just go ahead and put both points, 2, 4, and 5, 1. Nathan, was your question, what about all the others? Were you thinking about the infinite embedding in between? Okay. I was thinking you were wondering about all these. But the two vertices are locations, and there are infinitely others, but we're not going to stress about all the ones in between. Once again, our point was, who's the max? 12. Okay, cool. There is one other weird thing that can occur. Some linear programming problems, this is kind of like unusual characteristic number 2. Some linear programming problems have no optimal solution. And that's going to happen when the region is determined. The overlapping region is unbounded. The region determined by the constraints is unbounded. Let me show you a quick example. What if I was to show you something like, I don't know, let's do that, and then let's do like that. Maybe even something like this. And let's say our overlap was here. Uh-oh. Is it being cut off anywhere up top here? So if I was trying to find the max of this, guess what I would have to say? Now, is there a min? And the answer is definitely yes. Probably, depending on the slope, the min would occur at a couple of these lower vertices, like that one or this one. Maybe that one. So we can have weird regions that do have mins. There is a min. The min would be yeah, but the max would be no. Does that make sense? It's unbounded. The other way you could look at it is, let's say negatives were a possibility, which is true when you're talking about like profit and cost. Your profit could be a negative if you have more cost than income. But if you were to do something like this, let's say the overlapping region was here. Oh, it's not as pretty. That wasn't being as precise. Is there going to be a min of this one? No. Why? Because negatives are a valid option. If negatives are a valid option, this thing is unbounded, negatively speaking. So we can say, yeah, I'm sure there's a max. I'm sure there's a maximum for this one, but if they were asking for the min, our answer would have to be no. Not possible, there is none. Okay, personal finance, credit cards, you can keep on spending without having the money, and your debt just keeps on going down and down. Up and up and up.
Yeah. That goes down, down.
So what you have is more and more negative. You don't want negative money. It's a bad idea. Beware credit cards. Take personal finance. Okay, so. Oh, that's not it. Sorry. Is that the same homework you guys wrote down? Those of you guys that started 7-6 last time? I don't have it up here. Someone wrote it down, didn't you? Is that right? It might not be 49. What is it, 47? It's 47. But is that the right assignment so people can write it down? Aha! Go team. They deserve applause. Or maybe the rest of you guys just deserve scourging. Anyway, so.
I like the applause.
Oh, okay. Must be facetious. The struggle's not real. You guys still have like 15 almost minutes. How is the struggle real? And I said you can use your calculator on the long word problem ones. Alright, go ahead and get down over 47, section 7.6. And if you guys want, I'll show you the test review in just a moment. But you guys have 12 minutes of, no wait, over this weekend, on Monday morning when you come into class, and I'm like, how you doing? And you're like, oh. Like, who's tired? Everybody. Who got caught up this weekend? Nobody. You're gonna hope that you had more time. So you have 12 minutes for free. Use them wisely. Ready, set, go.
We have to pay for the other time.
Well, for free, you pay for it.
Nice put.
Sure, hi. I'll pick it up after school. Okay.
Anybody still writing the homework, going once, going twice? Sold. If you want the test review, here it is.
Yeah, but I don't think that does anything for you.
Okay, we have the same thing. Okay.